So this problem is asking for the minimum size of copper conductor that's required to serve two loads. One is a single phase 5 horsepower induction motor, continuous duty, 230 volt, and the other load is a heater, non-continuous, operating single phase still, 240 volt. So the question is asking for the size of the conductor. So you already know that you're going to have to calculate the total load amp, the full load amp, and then work your way up to get the corresponding conductor size using your 310 table. So let's see what we have here. It's always good to visualize what you got before you start a problem. So we have two loads here, a heater, 2 kilowatts, and then operating at 240 volt single phase. And then we have a motor, induction motor, to 30 volt. I'm writing the keywords here: continuous duty, and then 5 horsepower. So this is what we have. It's always a good idea to put what you got and then start from there. So in order to calculate the total loads, we do it separately and then add them together. So here for a heater, it's a single phase. So P is equal to, use a, that's fine, I can use this color. P is equal to VI. So the load amp, the full load amp, the load amp, is equal to I. P is 2000 watts divided by the voltage 240. So this gives you 8.33 amp. So that's how much the heater is providing. Now let's calculate the motor, how much it's calculating. Now here, how much it's providing. We're gonna have to use the NEC code. So the article on motors is 430, and there's some tables out there. Here the applicable table is 430-248, and as you start practicing problems, you'll kind of get the hand of it to quickly recognize that you got to go to that table. I can't really tell you how you know that. I can just tell you that make sure you go to the correct table, but you kind of get a feel of it as you go. But here, this table is 430-248 is the full load amp for a single phase, because there's another table for 2 phase and 3 phase as well. So here the problem is single phase AC motors, and there's another one also, I think, for DCs. So make sure you're on the right table. So we have a 5 horsepower motor operating 230 volt. So our full load amp is 28. So let's write that down. So here, full load amp is equal to 28. However, if you read the problem here, it tells you continuous duty. In the same article for 30, if we go to 430-22, I believe, 22 alpha or 22 bravo, one of them. Let's quickly go there, and you'll see that for single motor, so as soon as I see continuous, I'm multiplying by 125. So just memorize that part. But here, this is where it came from. Conductors that supply a single motor used in a continuous duty application shall have an ampacity of not less than 125% of your FLA, your full load motor full load current. So we already calculated our motor full load amp. So we multiply here by 1.25, and this gives us 28 times 125, that's 35. So don't forget that. Do not forget to, in a continuous duty, a single phase motor, to multiply by 125. You just memorize that. I mean, just remember that. Put that in your notes somewhere. You don't necessarily have to go back to that article, I mean that section, but just something that you just need to know automatically. When you see continuous, automatically put that somewhere in there. So our total load would be, of course, 35 plus 8, 33, and this is equal to 43, I believe. Yeah, 43, 33 amp. That's our total load. So now that we know the ampacity of the cable, let's use table 310 to get the corresponding conductor size here. Let's go to our ampacity tables all the way. .310. Oops. Okay. Almost there. So this is why you got to use tabs to get there quickly. So 310, not that one. Yep, this is the one. Allowable ampacitance of insulated not more than 3 current carrying conductors. So here in the problem, let's go back to the problem. We have THWN copper 75 degrees. Okay, 75 degrees. THWN copper, and our ampacity was 43. So that's as a minimum we have to use 8 WG, 8 WG. So you can't use this one because it's not enough, because you got 43 amp for your total load. So you have to use the next highest, I guess, if you will, and that's 8 AWG. It's a lot of table flipping, but it kind of becomes natural as you practice. So here the answer is 8 AWG conductor size. So you know, it's a lot of flipping, and so we use here 3 sections, I think, right? The full load amp for the motor, we use the continuous duty, and we use 310 tables. So it's like 3 NEC articles that we used in just one single problem. But as you practice, it kind of becomes natural. You don't even need to go back and flipping. Once you see continuous duty is 125%. The only thing you need to look up is your full load amp, single motor value, because you can't memorize those, and then, you know, your ampacity table. But it's not really that bad. So let me know if you have any questions.